Good morning, good afternoon, or good evening, depending on your time zone, and welcome back to the Spring Webinar Program. I am Peter Humphrey, your MC, as always. Today, I am very excited to be joined by one of my Spring team colleagues, Ryan Baxter, who is on the Spring Cloud team. Works with a lot of the Netflix open source folk in the present and in the future, and he's going to talk to you today about the upcoming Spring Cloud Finchley, of which there's already many milestone releases, but we're looking towards a GA pretty soon. And so, Ryan, maybe would you take a moment to introduce yourself, and then we'll get into the meat of the presentation.
Yeah, sure. So as Peter said, my name is Ryan Baxter. I do work on the Spring Cloud team, mostly focused on kind of the core Spring Cloud components around Netflix, config server, gateway, stuff like that. Yeah, that's pretty much my deal.
Awesome. All right. Well, let's get into it. You want to? We're going to talk today about reactive microservices, right? With Spring Cloud Finchley. So, yeah, I'm also very curious to hear a little bit about the reactive bits, but you know, I think there's still a lot of people curious about, you know, just API gateway in general. So yeah, let's take it away, Mr. Ryan.
Sounds good. Okay, so like Peter said, we're going to be talking about building reactive microservices with Spring Cloud Finchley. So that's going to be the topic today. If you want to get in touch with me, I'm pretty easy to find on the internet. I'm at Ryan J. Baxter on Twitter, at our webpage at ryanjbaxter.com. Of course, if you have any questions regarding Spring Cloud, Stack Overflow or Gitter is another good place to reach out. We, besides myself and my teammates, we're always there to help answer any questions, problems. You know, feel free to open issues on GitHub in the Spring Cloud projects. We're always willing to help. So, yep, that's the best place to get in touch with me. If you need me after the presentation, feel free to ask any questions at the end of the presentation as well, which would be awesome. So I'm going to answer the #1 question that probably everyone has if you're attending this presentation is, when will Spring Cloud Finchley be released, right? As Peter said, we've had a number of milestones. We've up to this point, we actually just a couple weeks ago released our first release candidate. So the answer to your question is actually all in the open. We don't hide anything. You can head to the Spring Cloud releases or Spring Cloud release project on GitHub. The URL is right there. And if you go to the milestones in that project, you'll see our plan as far as when the release is going to happen. So as everything's are very fluid, so the screenshot I have here, which I took last night at about 8 o'clock Eastern Standard Time, is already outdated. So we decided to change things a little bit more this morning in our team meeting. We're going to do another RC2. So we were planning to just do one release candidate and then go straight to the release, but due to some changes in Spring Boot, we decided to do, and some other changes that we know we have coming in, we decided to do another release candidate. So that release candidate will probably be released next week, end of next week, beginning of the week after. So it'll be RC2, and there's potential for an RC3 based on how that release candidate goes. So more than likely, the GA release of Finchley will happen in June at this point, but we have at least one other release candidate planned, and then a following, maybe another release candidate after that as well. But keep track by going to this URL here in the releases project. Like I said, whenever we make changes to our release dates, we put that all there so everyone can see what's happening. Okay, so some of the things we're going to talk about today. Basically, I have a couple of slides here, not too many slides, but we're going to talk about some of the key enhancements to some of the projects that have been made and that will be made in the Spring Cloud Finchley release. We'll spend a little bit of time talking about the Spring Cloud Gateway because that is a new project that is part of the Spring Cloud Finchley release. And then we'll do a little bit of demo, some coding, and hopefully spend some time with some Q&A. So let's get into the slides here. So just a little bit about Spring Cloud Finchley. If you're not familiar with it already, you may have poked around the code. I hope you have, actually, and I appreciate if you have and opened issues in GitHub. But for those of you who don't know, Spring Cloud Finchley is built upon Project Reactor, Spring Framework 5, and Spring Boot 2.0. So you cannot use Finchley with, a Spring Boot 1.5 X release. You have to be using the latest Spring 2 release, and we take advantage of a lot of the reactor pieces that are available now from Project Reactor and Spring Framework 5. So that's just a little bit about the architecture, what we're building upon. Nothing's changed there. We've always been dependent on Boot. We just decided to be exclusively dependent on Boot 2.0 in the Finchley release. So because we are taking advantage of a lot of the reactive pieces underneath us in the stack, you'll see a lot of changes to the various projects that involve taking advantage of some of those things. So for example, with Spring Cloud Vault, we now have a reactive Vault template, which provides a reactive API for interacting with Vault. In addition, we added support for Vault database backends, where Vault will create credentials for your applications, and the applications can then retrieve those credentials from Vault for your database services. One of the cool features that I think was added was support for Spring Data's repository concept on top of Vault. So just like you can create a repository for a Mongo database or any other type of database, you can now create a repository interface on top of Vault for retrieving credentials, for example, from Vault. And we've also added support for authentication with Vault using Kubernetes Service Account Token. So Spring Cloud Sleuth. So Marcin and Adrian, if you know them, they're both involved in the Sleuth project in Zipkin. They've been quite busy with their work in Sleuth and Zipkin. They basically decided this wasn't a decision that happened right at the beginning of our planning, but kind of in the middle of Spring Cloud Finchley, that they're going to rewrite Sleuth using Brave. So it was quite the undertaking, and they had a lot of work ahead of them, and they did an excellent job of getting all that done, plus more on top of that. So Sleuth now uses Brave as its tracing framework implementation. So Sleuth no longer takes care of storing the context for the tracing. It delegates all that to Brave underneath. So it's been quite a change for the internals of Sleuth. There is a migration guide because there are several things that are a little bit different now since we are using Brave. So Marcin has done a good job putting together, Marcin and Adrian have done a good job putting together this migration guide, explaining the differences and changes. So if you are a Sleuth user and you're looking to move your application to Spring Cloud Finchley, I suggest that you take a look at that migration guide and use that as you move your applications over. So like I said, besides that, they've added a bunch of other nice functionality to Sleuth, and there's a whole bunch more stuff that's been added. Actually, when I asked Marcin to kind of summarize the changes in Sleuth for the webinar, he gave me a laundry list of stuff. So I had to whittle it down to just try to fit everything on one slide. So there's now support for tracing when you use the web client from Webflux. So that's some more of the reactive bits. Also with Netty's HTTP client, and that's going to come into play when we talk a little bit about the Spring Cloud Gateway and the Apache HTTP client. So if you're using any of those in your new Spring Boot 2.0 apps, we now will add tracing to those HTTP clients. So we also now have added some new support for messaging, tracing with messaging. So we have support for Spring Kafka and Spring RabbitMQ. In addition, we've added support for Amazon X-Ray and Apache Dogo as well. So if you're users of those applications, you can take advantage of that stuff. Okay, in contract, again, there's a lot more than I was able to fit on the slide. I just took highlights here. We're going to kind of briefly touch on some of this stuff in the demo, but we have support for Rest Assured with RestDocs, support for Packed v3 with Packbroker. One of the features that I kind of like are the next two, so the ability to upload and fetch stubs from a Git repository as opposed to always using Maven. And then the ability to define contracts in YAML, where previously you could only define contracts in Groovy. I'm not much of a Groovy user myself, so I'm more familiar with YAML, so I like the ability to do that. And if you are interested in using contract with other languages, there are now Docker images available that can be used for polyglot support. So if you're using Node.js, for example, and you want to use Spring Cloud Contracts with that, you can now take advantage of these Docker images that are available for polyglot support. So that's another feature that
would you, just for our listeners that might not be familiar with Spring Cloud Contract, could you give like maybe a 2-sentence sort of, what is it sort of thing, just for anyone that maybe doesn't know?
Sure. So typically, when you take a look at your microservices architecture, you're going to have, this kind of dependency tree where one microservice depends on information from another microservice, which depends on information from another microservice, right? So when it comes down to testing these things, lots of times you as, the microservice B that consumes microservice A, you kind of mock up the functionality that you believe is present in microservice A so you can run tests against the functionality in your microservice that you're building. And that's all fine and good, but when the team that owns microservice A goes ahead and changes something about their API or whatever, you may not know about it, and all of a sudden your tests are passing fine, but in production everything starts to break down. So the idea with contract is that microservice A produces contracts about its functionality, and that way, if you're a consumer of microservice A, you can consume those contracts, and you have knowledge about what the expectations are, right? So instead of you interpreting the functionality of microservice A to run your tests, you're actually using contracts that are published by that microservice to run your tests against, right? So if the team that owns microservice A in this model goes ahead and changes something and changes some functionality, they change their tests, make all their tests pass, and then they publish these new contracts, well, all of a sudden your tests are going to start failing because there's some new expectation that you weren't aware of, and now everyone knows about it, right? So there's this kind of nice communication between consumers and producers that in this microservices environment. So it definitely helps out as far as testing in some complex architectures. Okay. Next up, Spring Cloud Netflix. So not too many new features here, just a lot of kind of cleanup, housekeeping type of things that kind of been lingering around in the previous releases that we have a chance to make some significant changes now in 2.0. So there's a new Hystrix.stream endpoint that can be used for Webflux apps. So it's a reactive endpoint if you're consuming information about Hystrix. There's also a new clusters endpoint. So if you're a Turbine user and you want to find information about the clusters that are available to Turbine, you can use this endpoint to find out more about that information. I think we've heard, I believe actually there was a webinar yesterday about Micrometer. So we're taking advantage of Micrometer in Netflix to collect metrics about Zool. Some interesting metrics collected about Zool using Micrometer. And these last two are more just kind of migration things that you should be aware of as you move from Edgeware or Dalston to Spring Cloud Finchley. OpenFeign, which used to be, or Feign used to be part of the Netflix open source umbrella, but was recently moved out of that project into its own GitHub project, so it's no longer under Netflix. And so we've taken Feign out of Spring Cloud Netflix and moved it into its own project, Spring Cloud Feign, so it's no longer part of Netflix. That's more just a housekeeping piece, but does have some implications as far as your dependencies are concerned if you're a Feign user. Also remove Spring Cloud Netflix AMQP, and a lot of the starter, actually all the starter modules that were in Spring Cloud or Edgeware and Dalston have been renamed, and the old ones have been removed. So initially, when you move from an Edgeware or Dalston release to Finchley, you might get a bunch of problems in Gradle or Maven because these starters no longer exist. So just a slight naming convention here. We've gone from Spring Cloud -starter to Spring Cloud Netflix starter instead. So you just have to type some extra characters in your POM or your Gradle file to get things to work properly. All right, same thing with config. Not too much as far as new features here for Finchley, but one of the cool things that we did add was support for database backend. So this is a long outstanding feature request that was in Spring Cloud config for a while. You could use GitHub or Subversion or file system or even Vault for the back end of your config server, but we've always gotten requests to support databases as well. So now we have a JDBC support. So if you're looking to use Spring Cloud config with a database, you can now do that. We've added support for Gitty webhooks. So if your Gitty is a different type of cloud-based Git repository, so if you're a user there, those might be of interest to you. And we've added the ability to skip SSL validation for both Git and Vault backend. So if for whatever reason, this can be somewhat of interest in certain situations, but if you don't want to validate SSL certificates, you can go ahead and skip that stuff in the Finchley release. All right, so sorry if the screenshot's a little hard to see, but we'll see this more in the demo. So the code's not so important, but as you know, there's a new web framework that's part of Spring 5. So we had Spring MVC, and now we have Spring Webflux. And you have a new web client where before we used something like a REST template to make HTTP requests. Now we have a web client. And in prior releases, you can added the @load balance annotation to your REST templates to take advantage of server discovery and load balancing, client-side load balancing. And we've added functionality so that you can now do the same thing with your reactive web clients as well. So when you move to a more reactive programming model, that will definitely be of use for Spring Cloud users. So, like I said, we'll take a little bit deeper look at that in the demonstration as well. And then lastly, I'll talk a little bit about our new project that's part of the Spring Cloud Finchley release. So that is the Spring Cloud Gateway. This, again, is built on Project Reactor, Spring 5, and Spring Boot 2.0, and it is the perfect use case for, or I shouldn't say the perfect, but an ideal use case for a reactive programming model. So if you think about what an API gateway is, it's the entry point for all of your clients into your application, right? So there's a high amount of traffic that will be coming through this gateway, and you don't necessarily, you have this scalability problem. So the more traffic you have, the higher you're going to have to scale your application. So with the reactive model, as I'm sure we've talked about in previous webinars, this allows us to consume, the reactive programming model allows us to consume a lot less resources when it comes to high traffic applications. So since this API gateway is kind of a central focus or will be a central focus in your architecture, it's a perfect use case for using things like Project Reactor and Webflux and stuff like that. So we've built the gateway on top of these concepts, and the nice advantage here is, besides being reactive, is that Spring Webflux provides a lot of functionality that is important for a gateway out of the box. So things like predicates. So deciding whether you're going to route a certain request to a backend service is important, right? So we can create predicates on a lot of different pieces of information. So things like headers or cookies or paths or the time of the day that the request came in, right? You can route based on anything about the request, and that's a little bit different than if you're familiar with using Zool. So where Zool, we can only route based on path. We have a lot of good functionality provided by Webflux out of the box that you can use in the gateway. The other thing that Webflux provides is this ability to apply filters to requests and responses. So if you need to modify the incoming request or response in any way, we have the ability to do that in the gateway. So you can do things like change the path or add a header. You can change response bodies. You can do anything you want, manipulate the request response in any way you really please. We also have the ability, using this functionality, to apply circuit breakers and do things like rate limiting, and just a lot of cool functionality that just wasn't possible with something like Zool in the past. Yeah, so we're going to take kind of a deeper dive into that in the demonstration. I keep on wanting to use my keyboard instead of clicking. All right, so speaking of demo, let's kind of jump into that. So, let me know if there's a problem seeing my screen, but I think it's working.
No, you're good.
So, okay, cool. So, okay. So
actually, I am seeing. Actually, hold on. I am seeing. Oh, there we go. Okay, now it's starting to come in. It's a little. There we go. We're good now. Sorry. Apologies.
Okay. So I'm taking. We're going to start here with this pretty simple application that actually my colleague Marcin had written initially, and there's just a couple things I want to point out about it before. Well, let me tell you a little bit about what the application does first. So basically, this is a pretty simple application. It has a single endpoint called /check here in this controller. And what this does is check whether a person is allowed to get a beer or not. So you can see we have this person checking service, and there's an API called should-get-beer, right? So the implementation of that service is this age checking person service here. I'll make that a little bit bigger so everyone can read. Basically, all this does is take a look at the person's age, and if they are 20 or older, they are allowed to have a beer. But if they are not 20 or older, they will not get a beer. So real quickly, I will see what the app does. It's pretty straightforward, but I'll show you how it works. So let me just start the application up here. Should be running on port 8080. And go to the terminal here, and we hit that endpoint. So 8080, and we're going to make a post request to localhost 8080/check, and we need to include the age. So if the age is 2, you should get, you're not okay to get beer, right? So we have a status of not okay. But if the age is 22, we see that the status is okay, right? Pretty straightforward, nothing mind-blowing. Maybe mind-blowing, but not too mind-blowing. Now, the one thing I'll point out here is that this is using Webflux, so you can see that we're returning a mono here. So just to remind you again, there are 2 reactive types, mono and flux, and here we are returning a mono of type response, right? So, and that response is just okay or not okay, as we saw in the example. Right? All right, so now we have, in this, I'll point out here, we talked a little bit about some of the new functionality with Spring Cloud Contract. Here are the contracts within this, this application, actually written in YAML, right? So whereas before you had to use Groovy, like I said, if you're not too familiar with Groovy, you might be more comfortable with YAML. In that case, you can write your contracts in YAML. So here we see just a quick example of what that would look like as far as writing contracts in YAML. All right, so we have a consumer of this API, this check API, and so let's take a look at that guy. So this also has a single endpoint, which is inside this beer controller. And the endpoint is at /beer. And basically, this endpoint consumes a person object, and it's going to call that beer, that check endpoint from our producer /check to see whether this person is allowed to have a beer or not. So if they are allowed to have a beer, right, you get a status of okay back. We'll return the string, there you go. If not, then you'll get the string get lost, right? And the person object that we consume just takes in a name and an age, okay? So what we're gonna do here, I'll just show you again quickly how this application works. And then we'll start changing things around here. So this should start up on port 8081.
Ryan. Yep, Ryan, quick audience question while you're booting up there. Will the API gateway support integration with OpenID Connect as a configuration?
So we are going to have the same support that was available with Zool, which I believe was just OAuth. So I believe that, I think OpenID Connect, I can't remember exactly if OpenID Connect supported OAuth or there's some integration there. But if it does, then yes. If not, then we wouldn't support OpenID Connect out of the box. But I'm not 100% sure on that. So if we go to, again, we're going to make a post. 81, oops, to /beer. And we're going to post a person with the name Ryan, and the age is 2. You can see we get the get lost response, but if I'm 22 or 222, you see we said, there you go, okay? So pretty straightforward. Now, the one thing I'll point out here is if we remember our producer was returning, was reactive, right? It returned a mono, right? But our consumer wasn't really taking advantage of that. They're using using the REST template, right? A traditional Spring REST template, which is not reactive, right? So we can move this over. Now, the other thing I'll point out is that we are taking advantage of service discovery, right? So this REST template, if we look at the bean, is load balance, right? So we can convert this over to be using Web Client, which would support a more reactive programming model. And we can take advantage of the new @load balance web client to do that, right? So we can go ahead and start changing this around a little bit. So we're going to return, the first thing I need to do is change the POM, actually. So instead of using Spring Boot Starter Web, we're going to use Spring Boot Starter Web Flux. And we're going to add a couple other dependencies here, actually, too. So we're going to add Spring Cloud Starter Sleuth. That's not what I want. Spring Cloud Starter Sleuth. Oh, IntelliJ, we're just really not cooperating right now. Cloud Starter Sleuth. Thank you. And then we are also going to add Spring Cloud Starter Token. Wow. Just not happy with me. Starter Token. Okay. So those are all our dependency changes. And we'll go back to the bean we were going to create. And now we can say Web Client Builder. And we'll change the name here instead of REST template to be Builder. And then we are going to return a Web Client Builder. So Web Client Builder. So nothing new or crazy here. The only thing we've done is added this @load balance annotation, which now supports web clients. Okay. I will add one more bean here because in addition, I want to do some tracing with Sleuth. So I'll add a sampler bean, and we're going to turn sampler.always sample. Okay. This is pretty much the same as previous releases, but you'll notice if we look at the imports that we're actually using Brave instead. Okay, so just a little bit of a change there. Now, if we go back to our controller here, we're no longer taking in a REST template, right? We're going to have a web client builder. That's our bean. So we'll have a web client builder. We'll call it builder. And then our constructor also needs to be changed here. So web client builder. And this dot builder equals builder. Okay. So we still want to make the same kind of request here that we were doing with the REST template, but we're going to use a web client instead. Okay, so here we are going to return builder.build.post.uri, and again, same URI, but since we're using a load balanced web client, we're going to, the host name is actually the service ID of our producer, which is beer-api-producer. Okay, and then we need to post a body. So, and then we're going to use body inserters and from object, and we're going to post the person here. I'll try to keep this a little bit more readable. And then we're going to call exchange to make the request, and then we're going to flat map the response object here. and we are going to take the response and say the body to mono, and the type that we're going to use is response.class, right? So we have this, just so everyone's clear, we have this response object for the response, right? So that's what we're converting the body to. And then we're going to flat map that and look at the response objects. And we will say we're going to switch on the response. And if the case is switch. Yeah, nope, not response. We want response.status. Sorry. Case is okay. Then we are going to return mono.just. There you go, just like we had before. And if the case, the default case, I'm sorry, yeah, default, then we'll return mono.just get lost. All right. So make everything happy here. Now we're no longer returning a string, we're returning a mono type string instead. And we don't need any of this code. Get rid of this. And everything seems to be happy again, right? All right, so now just to reiterate, we're using a web client builder here, a load balance web client builder to make the same exact request here before to our reactive endpoints at /check and returning a mono of there you go instead of just the string, right? Or a mono of get lost instead of just the string. All right, so if we rerun this, whoops. Rerun the app here. We should still see the same exact functionality. Okay, we start running, there we go. I said IntelliJ is not being too happy with me right now, it's just moving very slow. All right, so we're still on port 88.1. So if we make the same request, you see there you go, but if I am 2, get lost, I don't know if everyone can see it. Let me get this there. See get lost instead, okay? So the API is still working the way we want it to work, but now we're using Project Reactor instead. So now one of the things we can do here, just to show and demonstrate a little bit more of some of the new functionality is we can put a gateway in front of these two services, right? So let's go ahead and do that. So I'm going to create a new project here and using Josh Long's favorite place on the internet, Spring Initializer. That's all fine and good. So we're going to add a couple of dependencies here. Obviously, we're going to add gateway. I am going to choose not to use boot 2.0.2. I want to use, actually, that should be fine. No. Let's hope that's fine. Gateway, what else do I want? I want Eureka. For service discovery, I want Sleuth, I want Zipkin, I want, maybe we'll play a little bit around with Hystrix depending on what we have for time, but that should be good enough for now. And I'm going to put this in gateway-demo. All right, so create a new project here in a new window. And first thing I'm going to do here is just rename my application properties to application YAML, because I prefer YAML over properties, and you should too. And we're going to give our application a name, so I'll make that bigger. Application name, gateway. And I'm also going to set the port this is going to run on, because we already have something running on port 8080, so we'll run this on port 9090 instead. All right, and then we'll go to our application here, and we're going to create a couple of beans. So the first bean, just like before, I'm going to create sampler so we can trace some things. Oh, actually, that reminds me, I have to go back and make another point about our other application. So just like in the in the consumer, we're going to return the same type of sampler as before. But I just wanted to make the point here in our consumer that, as we'll see at the end with some of the tracing stuff, that the tracing, we are tracing requests made from our web client. So that was some of the new support that was added in Finchley 2.0 with Sleuth, right? So we can now support tracing with web clients in addition to REST templates. So back to,
Ryan,
yep.
Ryan, a couple questions. One was, can we use Feign as a reactive client?
So no, not officially. So there is an open issue for that in Spring Cloud Open Feign. Someone in the community has written some code for that, but it hasn't been merged in yet to the master branch. So if you're interested in doing that, that's still work in progress. I'm not sure if it will happen before the release. It depends on the contributor. So if you're interested in that, you can look for that issue in the Open Feign project and help that along if you want.
Cool, thanks. Oh, sorry, go ahead.
No, I was going to ask if there was another question or not. But.
Oh, yeah. Earlier, someone was asking what is reactive in this example, but I think you've addressed that. But anyway, yeah.
Yep, I can go back if there's still questions, but yeah. Okay, let me get back to this. All right, so we're going to create another bean here, and we're going to turn a route locator and route locator builder. So this takes in a route locator builder, and this is actually how we're going to define our routes in this example for the gateway. Now, I will say that besides using this Java API, that there are two other ways to define your routes. So you could optionally define routes in your YAML properties, your YAML configuration as well, or your properties, your application configuration, whatever you choose, if you want to. It doesn't make for a great demo, so that's why I'm not going to do that. But that's a perfectly valid way to do that. You could also define your routes in a database. So any database that we have a reactive database connector for from Spring Data, you could define your routes and store them in a database, and we'll pull that information from the database backend instead of either using YAML or Java configuration. Like I said, I'm just choosing to use the Java configuration just because it makes for a little bit better of a demo. But those are other options as well. So here we're just going to return a builder.routes.build. Okay, and we can start defining some routes here. So if we want, for example, we can create a route to our consumer API, to our producer API. And these routes take in a predicate spec builder. So this is how you're going to define some predicates to decide where your requests are going to be routed to. So, oops. there's a whole bunch of things you can use to help decide where things should go. So you can route based on the path, the host, like I said, the time of the day, whether there's a cookie, certain headers are present, et cetera, et cetera. So anything about the request you can match on and route, make decisions to route requests based on that. So in this example, we'll just do if the path is /check, and I'll show you another cool feature here that you can use logic in your predicate matchers. So you can say if the path is /check and the host is something dot producer.com, then we are going to route to a URI here. And the URI can be any URI, right? Any valid URI. But in this case, we want to use service discovery. And in order to tell the gateway that we want to do that, we're going to begin with a special protocol, LB, right? So LB stands for load balance, right? So we're going to say that we want to use load balancing, and that this the host name that's going to come after this is going to be the service name of the service we want to route the request to. So in this case, it's beer dash API dash producer. And just so everyone knows, I will just make a point of showing you that I do have Eureka running here. So you can see we have Eureka running, and our consumer and producer are both registered in Eureka. And I will make this a bit more readable. Second, you can see it all on one screen here. And then we'll define another route as well for the producer. So here we can see path. Again, we'll make the same path check, actually. Make this even a little bit more interesting for you. And we'll route to the URI load balance beer API consumer. Okay. So the way this is going to work is if I make a request to /check and this host is actually present, then it will route to this URI. However, if that host is not present and the path is check, then we're going to route to this URI instead, or this service, I should say. So let's give this a shot. So if we run this, right, and we go to, we're going to go to 9090 and /check, and we're going to add a host header here of producer.com and post a JSON object of name and age 2. You can see we went to our producer service, right? So we got that status not okay, but if I change the age to 22, we got that status okay. So that seems to be working. So if I get rid of, no. Come on, did it make me retype that? Guess so. Okay. 9090, we're going to go to check. Name is going to be Ryan, and the age is going to be 2. Now we get a 404 back. So why is that? I'll explain this because it's kind of important. So all the gateway is actually doing here is taking this request to /check, and it's going to forward it on to Beer API consumer, right? It doesn't, we don't have a producer host, so it's skipping this, doesn't match this, right? But it does match this route because the path is just checked, but it's just forwarding /check onto Beer API consumer. But Beer API consumer, if you remember correctly, its path is at its path is at /beer, right? Not /check. So we need to modify this request a little bit more. So we're going to do a little bit more magic here to get the gateway to route things correctly. So we can use a filter to modify the request, right? So we can say, here's an example of applying a filter. So this takes in a gateway filter spec, and here we can set the path, right? So this is how we start manipulating, in this case, the request. In this case, we're going to set the path to /beer instead of /check. And just for the heck of it, let's just modify the response too. So we can add a response header as an example. So we can add this response header foo with the value bar and the response that comes back. So just a couple examples of how you might modify the request or response using the gateway here. So if we restart the app here,
Ryan, as you're restarting, there was a question, does Reactive, and this is a great question actually, does Reactive imply using Netty, or can we use all this with Tomcat?
Yeah, you can use it with Tomcat as well. So by default, we do use Netty as the server in Boot 2.0, but you can change it to be any server, which I believe is Tomcat is one of them. Yep. All right, so let's just try this again. So this time, instead of getting a 404, we should get the response we're looking for, which is get lost because my age is 2, right? So, and if I change my age to be 22, you see, there you go, right? So those are just some quick examples here. The one last thing I'll show you, because it's almost been an hour now, so one last thing I'll show you is some of the tracing, right? So the reason why I wanted to do this here is because, again, one of the things that we've added support for in Spring Cloud Sleuth is the ability to trace the Netty HTTP client. And under the covers, that's what the gateway is using. So the gateway is using the Netty HTTP client. So just by adding this bean here, it means all of our requests from the gateway are going to be traced. So quickly, we'll look in Zipkin here, and we can take a look at the traces, right? So we see a number of things tracing, but we'll see that the requests are coming from the gateway in this case, right? Here's that 404 that we got the first time we configured our one of our routes there where it wasn't configured properly, it wasn't routing to the right place. We can see we got a response in 404, but this is all being traced from the gateway, right? And we can also see, again, traces coming from the consumer, et cetera, right? So we get all our tracing due to all that nice work and supported HTTP clients that were added in Sleuth.
Ryan,
yep.
Is there another question? Is there the same concept as pre and post filters in Zool? Can we in Gateway, as in Zool, provide dynamic filters on the fly?
I'm not sure what they mean by on the fly. They need to be configured, right? So here are examples of both a pre and a post filter, right? So here, this set path filter is an example of a pre-filter. So we're setting the path of the outgoing request that's going to be made, right, from /check to /beer. And this is an example, this add response header here. This is an example of a post filter. So this is modifying the response after the request is being made. I'm not sure what they,
sorry.
Yeah, I'm not sure what they mean by on the fly. Like,
I would guess what they mean is that, is there like an actuator endpoint or some way of modifying the pre and post filter predicates at runtime is my guess, but maybe the person that's asking could clarify if that's not in fact it.
Yep, if that's the case, then the way to do that stuff is to keep your route definitions in your YAML or your database, and then take advantage of refreshing the application using the actuator endpoints to refresh the app and update the configuration that way. So
cool.
you wouldn't want to use you wouldn't want to use Java configuration, right? So this is purely just for simple demonstration purposes. I think the better way to provide your route configuration is in YAML or via database.
I have a question that I've seen. He by the way, he confirmed that our interpretation was correct, so we did answer the question as appropriate. It just brought up another question that I think is probably in the minds of many of our listeners. Besides YAML or properties, like, is there a data store that tends to sort of best practice, get used when people do go the database route? Is a Cassandra a popular option, or like what do you see usage-wise, or what do you expect, I should say, since this is still sort of pre-GA product, but what do you expect people to pair this with if using a data store?
I don't think we prefer one or the other. I mean, we don't have any, we don't lean one way or another. If we have a reactive connector for that database, that's fine. That doesn't matter to us. That's really the only requirement. So whatever your data store of choice is, that's good with us. Yeah, we don't prefer one thing over the other.
Cool. Just curious.
Yep. So that's all I had for the demo. Is there? I'll go back to the slides real quick because I had one last slide. But if there are other questions, that'd be great. But again, ways to connect with me: GitHub, Twitter, my homepage, all that stuff. If you're looking for more information about Spring Cloud, we have our Spring Cloud homepage, GitHub repos, etc., samples, tons of stuff like that. And take a look at the attachments and links section, which has links to all the repos that I talked about and the code, as well as a link to the slide deck as well, if you're interested in that.
Awesome. There's one more question, but folks, while you're considering what you've seen today and you are, teeing up any last questions, like Ryan said, this is a good time to go into the attachments and links section of your user interface and look for follow-up links. Although there's clearly a number of them on the slide as well. So screenshot that or bookmark some of those other links down there if you're looking for more information. Also, we'd appreciate it if you take a moment to rate the webinar and maybe let us know what kind of content you'd like to see in the future. There should be a survey involved in that, and then realize that you can come to Spring One and learn a lot more, not just about Spring Cloud in general, but the rest of the entire Spring and Cloud Foundry, DevOps, infrastructure as a service type ecosystem and cloud native ecosystem. That is going to be in September 22nd to 24th to 27th, in Washington, D.C. And there should be a banner displaying across your screen now where you can click the link and get a $200 off early bird discount, which ends July 31st. 2018. Ryan will be presenting at Spring One platform along with the vast majority of the Spring team and lots of other leading technologists. In fact, I just learned a few days ago that we're going to have a decent chunk of the Netflix open source team there at the event as well, so we might be doing something special with them at the event. But at the very least, there's going to be a bunch of Netflix engineers wandering around as well. So excited for you to kick the tires on this. What are we at? RC1, RC2?
For RC1 right now, and RC2 should be sometime. RC2 should be sometime next week. So
fantastic. Okay, so we'd love your feedback on those release candidates. Excuse me. And I think if you're looking for bits, it's your usual Maven and Gradle coordinates. So you can just go to the the Spring project page, which there's a link to, of course, right there on the slide and in the attachments and links section. Plug the coordinates into your Maven and Gradle files. If for some reason you are, stuck on some sort of closed network, you're in the military or you work for the government or you're stuck behind 900 million layers of proxy servers for some reason, you can get HTTP downloads, of this stuff. We don't recommend it. We don't really make it very easy for you to do that either, but you can do it. It's possible. You can get there to repo.spring.io, which is our nightly build Artifactory server, and you can get HTTP downloads of this stuff there. We just don't recommend it because the experience is, well, not great. So I think with that, let's parse the last questions or two. Feel free to keep adding stuff in, folks, as we attend to this. And just recognize that also this webinar is recorded. The slides will be posted along with the webinar recording. We very highly encourage you to share this with your colleagues. The replay is available to you at the same URL that you used to register for this webinar is where the replay will be. We also post it to YouTube if you happen to be one of our YouTube subscribers. So not to worry there. But yeah, great thing to share with your coworkers, especially if you've been working with the Zool, the Netflix Zool project. This is something you're definitely, if your other colleagues are working with it, you're definitely going to want to take a look at this, as I think this is the real way forward and for the future. So Ryan, one or two last questions. Do all those examples with the route locator, can they be configured using YAML?
Yes. So the one thing that you cannot do in YAML that I did do with the Java API is, I'll just share my screen quickly again. Is you can't do the logic. So here where I ANDed these two predicates together, you could also do things like or whatever here, your logical operators. But in the YAML configuration, everything is automatically ANDed together, so all your predicates would be ANDed together, and there's no option to do anything else. So that's the only thing that you couldn't do in with the YAML configuration.
Got it. Okay, awesome. Let's see. Okay, and then there's one more question. Can the route locator work without service discovery? So Eureka. Yep. With just static service URIs. Yeah.
Yep. Service discovery is not a requirement. It was just I included it as part of the demo today, but definitely not a requirement. You could route to any static URI you wanted to. Sure.
Okay. That makes good sense. Okay, I think we've got everything. We've got a bunch of nice feedback for you and some ratings. And yes, in terms of votes, folks, now is the time to go to your panel, in your voting panel in the, your polling panel, excuse me, in the web user interface. Let me know what you want to hear about in the future. This will help us program what kind of topics you want to hear about. And I'm seeing a very consistent serverless trend recently. So we are very actively looking forward to more webinars on Spring Cloud Function, which is sort of your client side, and also a really cool project called Riff, where we're working on the server side of that function execution environment. So we'll be doing some webinars on that soon. Make no mistake. So cool. Let's see, Ryan, anything, it doesn't look like there's any last questions, so I think we can wrap it up. Anything else you would like to say before we call it a wrap?
No, just want to thank everyone for attending, and then, look forward to all the great feedback on the upcoming release.
Awesome. Okay, Ryan, thanks for your time. And folks, remember, register for Spring 1 before July 31st for $200 off. And we hope to see you at the event. We're targeting between 3,000 and 4,000 people this year. It's going to be pretty epic. 10 tracks, amazing presenters, all kinds of fun stuff. So hope to see you there. All right, everyone, have a wonderful day, and thanks for joining us.